is our speaker today? Well, he's Ben Hanson, and he's at Microsoft, where he's a senior security architect. He's actually located way up in Yorkshire, so traveling to the Excel...
North Yorkshire even.
Yeah, sorry?
North Yorkshire even.
North Yorkshire, oh my word. So we'll look for the icicles hanging from his overcoat. No overcoat today because it's a glorious sunny day in London. But Ben's role at Microsoft is that he's part of the global cybersecurity community there. And he's a recognized thought leader in Microsoft and other companies. He most often works with security leadership and security operations teams of the largest tier 1 and global systematically important, it says here, banks in the UK and beyond. In other words, he works for some big guys and ladies. Before joining Microsoft 4 years ago, he led the cybersecurity and infosecurity practices for a renowned US-based management consultancy. So, please join me in welcoming Ben Hanson.
Hello. Who's ready for the rail carnage tomorrow?
Yeah.
So, is the Elizabeth line going to be open or not? I can't get a straight answer on this.
Until about 4:30, it's good apparently.
Until 4:30 in the afternoon? Really? Why that? Yeah. Yeah, so I have to get from Paddington to Excel in the morning, and we'll see how that goes. So, hi everybody, nice to meet you. So, as you can tell, I'm very Yorkshire indeed. I'm actually from Atlanta, as Dallin mentioned earlier, in the deep south, Georgia. I have the accent dialed down a little bit. I can dial it up if you want. It's not as weird as it sounds. My mom's from the East Midlands, so Mansfield, born in Nottingham, so I have pictures of myself as a baby playing in little piles of coal, as you do in the East Midlands, so I am half British despite the accent. So, has anyone been to Atlanta?
Yes.
Yeah?
Workstations Conference, 1996.
You went into Atlanta or just the airport? Because everyone goes to the
Atlanta,
airport. Okay.
The city.
City.
What's the name of the
City of.
convention center? I can't remember.
Geez, I can't even remember now. It's been so long. I know what you're talking about. Georgia World Congress Center.
I think it's
Yeah.
one.
Wow.
Yeah, a long
Cool.
time. Workstations Conference.
So Atlanta has lots of claim to fame, actually. It punches well above its weight, but UPS is based in Atlanta. Coca-Cola was invented in Atlanta. Coke's based in Atlanta. Delta Airlines based in Atlanta. I mean, just because I'm going to talk about security, kind of a funny thing I saw there once. So Coca-Cola's secret formula, for their drink, supposedly, is written on a scrap piece of paper stored in a bank vault in Atlanta, in a bank in Atlanta. And a couple of years ago, they changed banks. So they escorted, this was seriously happened, there was a police escort up the street, armored car. I'm sure it was just a dog and pony show. There's no way that their formula is still written on a scrap sheet of paper in a bank vault. But let's just pretend that it is, okay? They were this parade going up the street, police, armored car, transporting the scrap of paper from the bank they used to the bank they were switching to. Who knows if that actually happened, but I mean, it's kind of an interesting segue into security, and when you think about the things that are sensitive, right? I mean, let's just pretend let's pretend you can't go on the internet right now and Google what the secret magic formula is, because you can do that. But let's pretend you couldn't. That's their sensitive IP. They lose that, they lose everything, right? I mean, that is their business. If they lose that, they lose everything. So, interesting seg. So, I love quotes. I don't know if you guys are like me in this regard. I absolutely love quotes. And my favorite quote at the moment is by an American economist named Thomas Sowell. And Thomas Sowell said, "There are no solutions, there's only trade-offs." That's right, isn't it? Especially in security. Like, if you've worked in security long, you know that's true. Like, there are no solutions, there's only trade-offs with risk. There's balances, there's tension in the things that you can empower people to do, or developers to do, or your business to do, And that tension, the other end of it is security. How do we make sure people don't get our secret formula written on our bank vault in Atlanta? So I'm not that interested in technology. Kind of a weird thing to say, right? I'm coming from Microsoft. So I started as a technologist, like a lot of you, and there's a British company now. They're owned by SNC-Lavalin in Quebec, but the company's called W.S. Atkins.
I work for them.
You work for W.S. Atkins still?
No, I am the employee of SNC Netherlands.
Okay, still.
Yeah, yeah.
Oh, right. Okay.
Oh, you don't believe me?
No, I do. I just didn't. I've never met one
Ben,
since I left.
she's a plant.
Okay.
Atkins.
Wow. Where are you based?
North Victoria.
Okay. All right. I used to be based down like in Leatherhead, Epsom, that in Surrey. Yeah.
You know what? They rebuilt the office. It's fantastic.
It was hideous. Woodcote Grove was hideous.
Yeah.
Okay. Oh, I forgot we were streaming. I shouldn't have said that. But if any Atkins people are on, I'm sorry. It was terrible. So I used to lead I was one of the leaders of the enterprise architecture team. Those sort of 18 enterprise architects spanning time zones across the world. And I grew up as a technologist, very into hands-on techie stuff. And then when I started to travel, as I started to lead that team and engage with other parts of our business, I found as I traveled, what was important to me in the IT ivory tower was not important at all to the people out in the business community at the coalface, doing actual business work with customers, at the coalface daily with customers. And that kind of ruined it for me. And I started to think, okay, there's limits to what you can do with technology. And actually, maybe technology isn't the focus. Maybe it's more on transformation and business and, what are the business's objectives and not so much what tech can we deploy and that kind of stuff. And so that kind of ruined it for me. So I joined Microsoft because a lot of the things that Microsoft is doing now is still, in the security industry especially, is quite countercultural. Like, you may not know this. It's very popular now to hear messages in the security community about identity being the modern perimeter. Have you ever heard that kind of terminology, like we're moving away from network-centric based security to identity-based security? Well, Microsoft pioneered that. I don't know anyone that was talking about that the way Microsoft was before Microsoft did. That message is still very countercultural in the security industry today. When you hear people talk about things like zero trust, you still find they're talking primarily about network-based controls, which is important, but it's only part of the conversation. So we're going to talk about some of these things today. I love quotes, and so we're going to look at 4 quotes. Now I have ejected Mr. Charles Darwin from my deck. I'm sorry, I've replaced him with someone equally as distinguished, one of the lead engineers in Microsoft, because I just thought the message was a little bit more timely. The stuff I'm going to talk about today, as Dala mentioned, I work with systemic tier 1 banks mostly. And what that means is these are the banks that are too big to fail. So there's 3 systemic banks in the UK. Anyone want to give it a go?
Barclays.
Yep. Barclays?
City. No?
Which?
City. No?
Barclays?
HSBC.
HSBC? Nope.
Noise?
Nope. Liverpool? Standard Charter. No, Standard Charter. Yeah. Those are the 3 systemic banks. Lloyd's, they're huge. You've got Royal Bank of Scotland, TSB, there's loads, right? So there's lots of big banks in the UK, actually. We're blessed in that regard. So I work with most of those, and I'm going to give you anonymized stories of utter nonsense. And that will help us to illustrate some of the things we're going to talk about today. And we're going to start with this quote, which is a real doozy, if my clicker will work. There we go. Eric Hoffer is a 20th century American philosopher. It's cut off at the bottom, and he said, "In times of change, learners inherit the earth, while the learned find themselves beautifully equipped to deal with a world that no longer exists." How good is that? I love this quote. I use it all the time. This is one of those quotes that you can make about anything. You can make it about security. You can make it about bread. You can make it about whatever you want. It's just a great quote. If you took away one thing from today, here's the thing I would want you to take away. All sustainable transformation is ultimately a transformation of culture. Technology enabled, yes. Technology supported, absolutely. But ultimately, all sustainable transformation is a transformation of culture. And that theme is going to be something we're going to talk about a lot today. I laughed about not being a techie. I totally believe in technology. I wouldn't be working for a company like Microsoft if I didn't. But in those times where I would go out and work with other parts of our business when I was younger in my career, when I was with Atkins, what I learned was, not just in security, but security too, it was the people dynamics, it was the process dynamics, it was ultimately the cultural dynamics that were the undoing or the success long-term of what we were doing as an organization. It wasn't the tech. You need the tech, but it wasn't the tech on its own. So one of the things I've discovered is that businesses, hopefully this doesn't sound like your business. If it does, just laugh to yourself. But businesses that struggle to drive change don't have a technology problem. They have a culture problem, which is ultimately, frankly, a leadership problem. When businesses don't evolve, they look a bit like this. Now this is, just look at that for a second. You've got a car being pulled by horses. And I call this the kind of horse and buggy paradigm, dragging what you know from the world that was into the world that is, where that has ended, but you don't know it yet. And so you have this horse and buggy paradigms in a car world. Now I get it. So security organizations today are in a real place of transition between the world that was and the world that now is. There's, in cloud especially, there's different risks. So for the people who are more technical in the room, if you think of something like traditional Active Directory, which has been around, on your networks, running on your servers for 22 years now, the way that you attack that from a security perspective is completely different from the way you would attack Azure Active Directory in the cloud. It doesn't even speak the protocols that the on-prem tool uses. So the risks are completely different. The mechanisms, the metrics of attack are different, and so therefore you have different mindset, different kinds of tools, different approaches. So security organizations are in this position of transitioning between the world that they knew and the world that now is, and they're all trying to catch up for that. Now, while it might have been the case early on in cloud, where you had people in the business putting cloud subscriptions or accounts on personal credit cards and spinning up environments that IT didn't know about and that kind of stuff. Technology is not the limiting factor today. Like that's not the limiting factor. The thing that I most often see, the issues that I most often run in are this. It's security organizations in particular that have not made the transition from the world that they've known from the last 20 years to the world that exists now. And they're trying to take the tools and the processes and the way of thinking about security and drag them and connect them into their cloud environments, and they're wondering why it isn't working, why they're getting hacked, why it's expensive, right? And this is not a failure of technology. This is a failure of transition. It's a failure of culture, ultimately. So what are some of the characteristics that you can look for, to use Eric Hoffer's language? The learners inherit the earth, while the learned are beautifully prepared for a world that no longer exists. What are some characteristics that typify a learner versus the learned? Now, does that language make sense? Like, if you're a learned person, I'm using this language in a particular way, right? You're an expert. So you've been doing this for a long time. You got it all figured out. You know how it all works. The problem with being an expert is that sometimes you don't recognize when shifts happen. And it's hard to go from being an expert to being a novice again, right? So we see this all the time in the IT industry. Infrastructure people, up until not very long ago were people that were racking and stacking servers. They were going to data centers. They were plugging in network cables. They were setting up network equipment. They were doing things like that. Infrastructure people now are writing code. They're deploying stuff as code to cloud environments. They're not necessarily doing work with the hardware anymore. They're deploying code as hardware, as software, using software code to deploy virtual hardware into cloud environments, right? So there's been this huge transition. So what are some of the things that typify people that have learned to make this shift versus people that are still a little bit stuck? So number one, traditional mindsets and architectures. This would be like the learned, the people that haven't changed, versus modern mindsets and architectures, those that have changed, the learners. Well, traditionally, vertical thinking and funding, best of breed focus. So what does that mean? One of the examples I'll share with you, a large bank that we all know and love, unless you're in one of the many communities where they're closing branches, they only know how to deploy security tools, security capability through a single project. And the project is very tightly focused on a particular set of deliverables. I mean, if you're a project manager, that probably sounds reasonable. The problem with that is that the horizontal story, the end-to-end security story gets lost. And so you end up funding slices, vertical slices. You end up investing in this particular tool for this project and this particular tool for this project. And this is how you end up with the current state of affairs that we have in the world with security teams that have 70, 80, 90, 100 tools. Too many tools, and they're all disconnected. None of them talk to one another. And attackers know that in those gaps between those silos, that's where they live, because those silos don't talk, and they live in those silos in between those gaps. And so vertical thinking, vertical funding, best of breed, that means I've got a particular use case. I need to find the best tool that I can to do that one thing, and there's no thought about how that tool integrates horizontally with everything else that you're doing so that you have an end-to-end security capability. You end up with just lots of vertical niches. On the other hand, of course, you've got modern mindsets, horizontal thinking, best of platform. This is one of the areas where Microsoft really excels. So in my role, my job is to be a trusted security advisor for my customers. It's not to be a Microsoft fanboy. I will often say, here are things we do well, here are things we don't do well, right? And like many of you, I was in the company 4 years, but for 20 years before that, I sat across the table from Microsoft, and I know that they can be salesy, they can be, pushy on licensing and stuff like that. So there are things we do well, things that we don't do well. One of the things we do really well is we have a suite of security tools. If you're a really large enterprise and you invest in E5 licensing, for example, and you get lots of different tools, all of those tools on the back end are connected together. It might not look like that on the front end, but they share lots of information on the back end. Threat intelligence is shared. There is a common security platform called the Intelligence Security Graph, where teams like Mystic, which I'll explain in a few minutes what that is, take threat intelligence that they see coming into our data centers. We're talking trillions of authentications a day, many, many attacks. So Microsoft and the Azure data centers are attacked probably as much, almost as much as the US federal government. So they're taking this information, they're operationalizing that threat intelligence, publishing it to the security graph. All those security tools are picking that threat intelligence up on the back end, all of them, and operationalizing it automatically. So there are some things that we do really well, and that's one of them. The next one, look here, it says security strategies are bottom up, divided into vertical fiefdoms. Security strategies are top down and horizontally integrated. We kind of covered this a little bit, so I'll give you an example. Same organization that I mentioned a few minutes ago. So they have developed a monitoring strategy as a result of the way they fund security tooling, where this tool puts its logs here, and 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 they're all different places, and they're trying to, then in the back end, in their SIEM tool, which they use Splunk, but it could be any SIEM tool, trying to stitch all that together. There's no cohesive strategy, okay? And you see this a lot in identity as well. We talked about the central role of identity in security, and often identity is divided among 8 or 9 teams. You've got traditional joiners, movers, leavers processes. You've got identity security. You've got single sign-on and identity administration, password resets, that sort of stuff. And never the twain those teams meet. So there's no consistent identity strategy. There's 10. Everyone has their own. And trying to stitch all that together is a real challenge. But actually, modern mindsets, these organizations, they work out ways to have strategies that are not vertical, they're horizontal, and they're integrated with one another. So even if you have different teams doing different strategies, there is a layer of governance, a layer at the architecture layer, stitching the pieces together and saying, no, we need a cohesive end-to-end capability here. Here are our requirements. Here's what you must deliver. Traditional perimeter thinking, this is the third one. We talked a little bit about this already. So if you haven't heard that paradigm before about identity being the modern perimeter, if you think, especially now after COVID, if you think about how many people's businesses are still mostly working from home, just a show of hands. Yeah, okay. So before, everyone was in the corporate offices, the IT teams have a defined set of IP ranges. They know where those offices are. They know people are coming from those offices when they hit the internet, when they access tools. Well, that day, that's over. Right now, they're all spread to the 4 corners of the earth, literally. So like when COVID hit in the States, a lot, Microsoft's based in Redmond, Seattle on the West Coast in the US. A lot of the folks that lived there, the corporate guidance was as long as you agree with your boss and you get your job done, you can work from wherever you want. If you go out of the country and you incur tax liability, you accept the responsibility for that, not the company. But a lot of people on the West Coast, some people I know, they went to Hawaii. They were working from Hawaii, like probably on a beach with a laptop, So the scenario now is you've got phones, laptops, computers that are not owned by the company, people accessing company resources potentially from machines at their house that their wife and their kids use. All different locations, coffee shops, airports, train stations, and the corporate office. And all those access scenarios, oftentimes the one unifying factor across them all is the user's identity. The devices change, the locations change, everything changes. But their login, that corporate user's login, is the common factor across it all. And so this is the reason why, in this day and age, identity is the modern perimeter, because if you own the identity, you own all of that, right? If you own that identity, you get access to everything that user can do in all of those access scenarios. So in the digital world, identity is the key that unlocks all doors. There's 6 pillars we talk about. We talk about zero trust and perimeter thinking. Network is still a really key aspect of zero trust, but there's 5 other pillars as well. We talked about one already. It's identity. The others are data, networks, infrastructure, and devices. Those are the 6. Any zero trust strategy, if you have people talking about zero trust network access, any strategy that does not address all 6 of those is deficient. Apps have an identity, don't they? Devices have identities. Networks have identities. People have identities. They all have identities, right? All of those access control decisions, the point of zero trust is you're taking all of this information coming from all these sources and you're synthesizing it together and using all of those factors to make access control decisions. Well, if you're only focusing on the network layer, you just simply don't have enough information. So it's really important that it's not just about traditional perimeter thinking. It's identity perimeter thinking, but it's containment in all 6 domains. And then the last one here, characteristics of learners and the learned. Non-compliance is discovered versus non-compliance is prevented. Another company that we probably all know and love, I was working with them not too long ago, and they said, we have a big problem. Our group security function has done some scans of our, in this case, their Azure environments, found thousands of vulnerabilities misconfigurations, running images that were not patched properly, thousands of issues. And I said, and they said, oh, you guys have some clever tools. We want you to, help us fix this. And I said, well, how did it get like this? And then they proceeded to explain this really convoluted, well, the group guys, they kind of own the top level sort of security requirements. But this one business unit of our 7 or 8 business units has decided they're going to do Azure. Everyone else is doing AWS. And, we didn't really have any like security requirements. We just we sort of figured it out on our own. And, so what it comes down to is actually they don't have a failure of technology. It's culture, but it's security governance. Have you guys ever heard that 3-letter acronym GRC, governance, risk, and compliance? Ever heard that? Some smiles in the room. So one of the things I tell our customers is, if you don't govern your environment well, you cannot manage risk and compliance well. So like the order of the letters is really important. And so they're focusing on, we have this non-compliance issue with all these resources that are not configured properly and all these security risks, and the group guys are yelling at us and they're going to turn us off, and we need to fix the compliance issues. No. I mean, you do need to fix that. But how did you get here? It's a failure of governance. So they had effectively no ability to say, these are our requirements, and then translate that into policies, other kinds of controls that enforce those environments in their environment, right? Enforce those requirements in their environment. So that failure of governance resulted in lots of non-compliant issues, but ultimately it was a governance failure. So if you don't govern the environment correctly, you cannot manage risk and compliance in that environment. So what we did was we went back and said, right, how did you get here? What's the root cause? Let's fix that as we also patch the stuff. Because if you don't do that, what happens is you patch all the stuff, and in 6 months, guess what? You're back where you started. We're having this conversation again. Except this time, it might not be we discovered we have all these problems. It might be we just got hacked and our network got melted. Help us, right? So what characteristics of learners versus the learner, organizations that are learners that have evolved and are maturing in this sort of brave new world, they're not spending their time trying to find non-compliance. What they're doing is you've heard that terminology, shift left. So they're shifting left in the application development process, and they're saying, hey, we're going to take our controls for our security requirements, we're going to embed that into the application development process. Not so we can find stuff that's non-compliant later, because that's too late. What we're going to do is we're going to prevent it from ever being non-compliant. So you can't deploy code in our environment if it's non-compliant. It will kick it back to you, right? That's the difference in the way a modern organization approaches, in particular, cloud. So next, here we are, Mr. Churchill. Now, the stuff we were talking about a second ago has an organizational component, not just an organizational component. I love this quote too. This is Winston Churchill. So after the House of Commons was bombed in World War II, part of World War II, and the Parliament was trying to debate how to rebuild it. And Churchill made this quote. He said, "We shape our buildings, and then our buildings shape us." See, at the time on the continent, it was very popular to construct houses of parliament, senates in semicircular shapes. So if you look at other countries, you'll see that. You've got, just like the US Senate, right? You've got a giant building, all these kind of arch of people, all focused on one point at the front. Churchill said, "We shape our buildings and our buildings shape us." In other words, the shape of this building, the House of Commons, is a really important part of how we interact with one another. We don't want a semicircle where we're not facing one another. We're looking at one person at the front. We face one another. We square off with one another. We yell at one another during Prime Minister's questions, right? And the shape of the building, the way we interact with one another, is a really important part of our culture. It actually shapes the way that we operate. That was his point. Now, you may have heard the quote that every line on your organization chart cuts your ability to communicate in half. You ever heard that? Some of you are thinking about the size of your organization charts. Here's a better one. That's a good one too, but this guy, Melvin Conway, he wrote a thing called Conway's Law. He was an application developer in 1967. He said, I'll read it twice, it's a bit long, but wrap your head around this, it's really good. He said, any organization that designs a system will produce a design whose structure is a copy of the organization's communication structure. I'll read it again. He's using the term system really broadly. Could be an IT system. Think of an IT system. Could think of an application. Think of the way an organization interacts with one another. He said, an organization that designs a system will produce a design whose structure is a copy of the organization's own communication structure. In other words, input complexity influences output complexity. So if you have a really convoluted organization structure, like the example that I said a minute ago, like, well, the group guys do this piece, but then these business units own these slices, and then it's not, no one's really sure who owns what, and it's, you gotta check with this guy, but he's not really in charge, but he's kind of in charge, but not in an official way, you know, all that stuff, right? If you have all those complexities to work through, well, it's no wonder that you produce architectures and designs that are very complex because they reflect the way the organization communicates. You've got to talk to 1,000 people to get anything done, so of course it's going to be complex. The output's going to be complex. That was his point. Now, it's not just about organizations. There are cultural implications to this, coming back to that word again. So, you know, if your organization struggles with ivory tower thinking, fiefdoms, turf wars, almost always they have a really convoluted organizational structure. The way the organization relates to one another tends to be really complex. Now, we've talked about some kind of high-level stuff. I'll give you something a little bit more practical. Now, this is an eyeful. You'll have to look at this later. Don't try to digest this right now. But people are always asking us, okay, Microsoft, you work with every company on the planet who's transitioning from the traditional world to the cloud world. You're telling us we've got to do something different in the way that we think about and approach security. Well, what does a modern security organization look like? You're talking to us, you're saying organization structure matters because it influences the outputs. What does a modern organization structure look like? Well, this is it. This is what we advise people. Now, just really high level, you've got organizational leader setting things like business model and vision, risk appetite, risk oversight, driving down into your security leadership. That's driving down into, this is where leadership and culture lives, risk management, policy and standards. This comes down into technical risk management, which is, you know, compliance management, security architecture. This drives over into kind of operational, this says build, so kind of day-to-day operate and run. And we use these categories in Microsoft. You've got people, apps and data, infrastructure and endpoint, identity and keys. And then if you've got operational technology, if you're a pharma or manufacturing and you've got lots of IoT or OT devices. These connect into what's kind of ring-fenced here, Security Operations Center. Different companies call it different things, CyberOps, SecOps, whatever you want to call it. This integrates with threat intelligence, which is like the nerve center that's feeding signals back to the organization about things they need to know to take account of in their access control decisions. But the piece I really wanted to point out, you can look at this later. We have some nice slides that kind of build on this and explain it more. This is the bit that people haven't figured out yet, posture management. So posture management is people whose job it is to sit every day. It's the active governance of risk. It's not Jimmy on the help desk. It's not the guys that do this with some side work. These are people whose job it is to sit every day, all day, and look at in real time what is the security posture of this organization. And that information comes under things like, in the Microsoft ecosystem, it will come under things like conditional access. Some of you guys know about that, secure score, but also things like threat and vulnerability management. You know, those are kind of rolled up under what is now being called sort of posture management. There are posture management tools. You may have heard CSPM, Cloud Security Posture Management. one of the terminologies that Gartner invented. But posture management is a piece that is still missing. What typically happens in most organizations is people either don't do this at all, or they give it as kind of side responsibilities to other people who already have a day job, and it doesn't really work. So just a practical thing to take away, have a look at this later, maybe see how your organization addresses this. Let's look at the third one. We're moving down the stack a little bit. This one punches a bit. So this guy, Michael Hayden, former director of the NSA and CIA, he said this: fundamentally, if someone wants to get in, they're getting in. Accept that. What we tell clients is, number one, you're in the fight, whether you thought you were or not. Number two, you are almost certainly already compromised. Okay. What is this about? Assume breach. You guys heard that? It's the one ring to rule them all, so that's hence the visual. I was really proud of that. You've got basically three principles that are sort of the root of zero trust, okay? You've got assume breach, that's one. It's the parent, and I'll tell you why in a second. The others are verify explicitly and least privilege. So those are the three principles of zero trust. If you're looking at Forrester, if you're looking at the NIST zero trust model, they'll articulate it a little differently, but that's the gist, right? Assume breach, verify explicitly, in other words, make no assumptions, least privilege access, okay? Now, assume breach is the parent of the other two, and the reason I say that is because something like least privilege is something you would naturally do if you operated from the expectation that you were going to get hacked. Because configuring access permissions, for example, in a least privilege way would be an effective way for you to then minimize the damage that attacker could do once they got in, right? So if I'm not throwing out really high elevated privileges willy-nilly to access my servers or my infrastructure or my services, and I'm very tightly constraining what administrators can do, that least privilege, I'm protecting myself so that when I also adopt this principle, assume breach, I'm operating under the assumption that privileged administrator's account is going to get compromised eventually. And I want to make sure I can limit the damage that the attacker can do to me when that happens. So assume breach is the parent because it really is something that you would do. Least privilege, verify explicitly is things that you would actually naturally do if you operated from the assumption that this was going to happen. Now, it's very disruptive. Taking this principle and implementing it into the way you think about and conceptualize security is very disruptive because it turns traditional security priorities on their heads. So how so? Consider this question. You see it here. So think of a sensitive or a critical asset in your environment. It could be code, it could be an app, it could be data, it could be Coke secret formula. If you operated from the expectation that an attacker was going to compromise it, so when, not if, what would you do differently today to prepare than what you're already doing? Interesting question, right? Now, most people don't think that way. If you guys have seen in the news, there's been a series of attacks based around a vulnerability detected in an open source piece of software called Log4j. Have you guys seen that floating around in the news, Log4j? So Log4j didn't practice assume breach, the people that built that software, okay? What happens is, great system, right? I mean, it was invented a long time ago. Times change, software hadn't caught up. Okay. Log4j, there's this Java component that looks at this log file, and when someone drops something in the log file, it grabs it and executes it. And it doesn't ask any questions about what it is it's executing. And the idea is, well, but you should protect the log file so that random people can't just insert strings of information into it. Yeah, okay. But again, assume breach. Well, but if you operated from the perspective that no, someone is definitely going to insert something into that log file that's going to go out to a website where there's going to be malicious software on the other end of it. That's definitely going to happen. So is this a good architecture? No, because it doesn't do any kind of input validation at all. It just grabs it, oh, click that, install, right? So Log4j was this huge problem because software developers, they're not being lazy, it's just they take open source components because they don't want to have to code all the pieces themselves. So they're creating a complex application package. They don't want to write every single component. Log4j is a very common component that you can add into your application that provides this bundled ability to create logs from your application. Well, you don't want to create that on your own, so everyone just grabs Log4j and sticks it into their app. Well, it's open source, it's probably secure because, you know, open source software is always more secure because more people look at it, right? Okay, that idea is out the door. That's not true at all, obviously. So you have millions of applications with that application embedded in it. And a lot of people don't even know it's in there until, whoops, an attacker figures out, oh, check out the crazy behavior in this application. Let's have some fun with it. So if you look at this, again, a bit of an eye chart, but what this is showing is basically a high-level software deployment process, planning, coding, testing, production. All along the line here, these red boxes represent different types of attacks. The darker red ones are more sort of IT-oriented. The lighter red ones are sort of more developer-oriented. But let me ask you some questions. So if you operated from the assumption, assume breach, what would you do differently to prepare if you operated from the assumption that your privileged identities were going to be compromised? Well, one of the things you probably would do is you would spend a lot of time on what I mentioned earlier, least privilege. You would spend a lot of time thinking about blast radius. Okay, our most privileged admins, eventually someone's going to get one of those passwords. How do we limit the damage they can do to us when they do? Not if, when, right? What would you do differently to prepare if you operated from the assumption that your developer or privileged administrative endpoints were going to get compromised? So you see on the list here, the developer workstation. Now imagine if you're an attacker and we've all heard of the SolarWinds attack that happened December a couple of years ago that started with the attacker injecting their own code into code that compiled to create an application that everyone then dutifully installed. Well, if an attacker can get on that developer's workstation, I mean, they can just insert stuff into the code as they're checking stuff into their deployment repos and all that kind of stuff. So if you operated from the assumption that your privileged admins, your developers, were going to have their workstations compromised eventually, right? What's one of the things you would do? Well, one of the things we tell people, and you'll see this in the advice that I share in a minute, is if for privileged users, you should not be using a productivity machine to do privileged functions. So the most common vectors of attack: email, malware, yes, web browsing to malicious websites. Well, you've got your admins using a computer with email and web browsing on it. So you're actually increasing the risk that they're going to get hacked, that machine's going to get compromised. So one of the things you might consider doing if you assume that was going to happen was, okay, let's actually have those guys use computers that don't have email and don't browse the internet. And in Microsoft, we call those secure admin workstations. We have 30,000 of them in the company. They are physically separate devices. They don't have to be physically separate necessarily. That's the best way. If you're a developer that works on really sensitive source code in Microsoft, you cannot touch that code through a normal machine. You have to use a SAW. And there are security controls built around those to ensure that you're coming from a SAW device. We set these up all the time for customers, and we call them privileged access workstations normally. Your supply chain was going to be poisoned. You know, we talked about that, what would happen. So a really interesting area right now is the security of machine learning data. So just like with the Log4j thing, where you have developers grabbing open source modules and inserting them into their larger projects, A lot of the data that data scientists use to train their machine learning algorithms comes from public repositories, public data repositories. And a lot of those data repositories are not curated, are not very well curated, or they're not well protected. So you end up with a scenario where attackers, and this is happening, this is not sci-fi, and this might happen in a year or two, you should get ready. This is like, no, this has been happening for several years now. This is the scenario where the Tesla interprets the stop sign as a 50-mile-an-hour go faster sign. Because someone intentionally poisons the data being used to create those machine learning models, the AI brain, if you will, and things like that, intentionally poisons the data knowing that if they poison it in a certain way, they'll be able to produce a certain kind of outcome. And because they poison it just a little bit over time, no one sort of knows, and the developers are not thinking about this. They're not thinking about what happens if someone poisons our data source on purpose. Like on purpose, like why would somebody do that? I don't know, people do that stuff. And so the whole subject of machine learning, artificial intelligence, you're training these things to operate based on massive pools of data that you use to train them with. You use the data pools to train them on how to make decisions, and then as they make decisions, they get it wrong, they get it right, you tweak the algorithms, and you keep going until you get it accurate enough for whatever your use case is, okay? But if people can poison the data sources, they can affect how that machine learning model learns, and it produces the wrong outputs, and it can produce the outputs that you want it to produce, and that's the scary bit. So the security of machine learning. So again, if you were going to operate from if you were a developer creating machine learning algorithms and you adopt assume breach as a principle, you'd be thinking about how can I detect very subtle skews in my data? How can I detect outcomes from my machine learning models that are skewing in a direction that I can tell looks kind of intentional towards a particular outcome that's not the one that I want, right? But oftentimes they're not thinking about this sort of thing. We talked about source code, sensitive data exfiltrated. You know, if you operated from the expectation that your sensitive files were going to be stolen from you, and this happens a lot, and most malware now, when malware attacks a few years ago, malware attacks, you know, and you get the encryptor and it encrypts all your files, and then they send you a thing and says, give us, you know, $1 million and we'll decrypt your files again. What people said was, aha, well, joke's on you, I backed up all my stuff. So I'll just restore my backup and I'll have all my files back on to pay you anything. So what the attackers started doing is they took all these files, they encrypted them, and then they went through them and they found the really juicy stuff, the salary database, the Coke secret formula, right? And now they're saying, give us money, and they say, oh, we'll just restore our backup, and they say, if you don't give us the money, we're going to release this information publicly. This really sensitive stuff we just took from you. So now they've taken the power back, right? So if you operated from the expectation that people were going to exfiltrate your really sensitive information, what might you do to combat that? Well, one of the things that we do, certainly in Microsoft, is let's come up with data protection mechanisms that travel with the data. So we're not focusing on protecting the file server. Don't care about the file server, really. Don't really care about the storage accounts. Don't really, I mean, we care, but you know, it's better not to have it exfiltrated, but let's say it does get exfiltrated. What if we embed security in the file itself, so in Office files and PDFs, the ability to apply rights management to a file, a Word document, I label it, this is sensitive, that applies a particular set of encryption policies. Now, if someone steals that document, they can't read it because it's encrypted. And I control who gets to access it, and I can actually centrally revoke that because the protection baked into the document, when you open the document, it calls home just to make sure no one's revoked access to it first. And if they have, you can't open it, right? So this is about, okay, you've stolen all our stuff. I'll just restore our backup. No, but some of it's really sensitive. Yeah, but you can't read it, so, I mean, I know that you can't read it. It's encrypted, so, you know, you really can't extort me. Right, so this is an important consideration. Things that you might naturally do if You really adopted this idea of assumed breach. The reason I say it's disruptive is because you can see how it turns paradigms on their head that people might not really think about. But when you think about, if I operate from an assumed breach perspective, you're thinking about how is someone going to attack this and how can I address that ahead of time rather than being reactionary, right? And it really changes the way that you look at the world and the way that you think about security. It's very important. Now we're getting a little closer to the metal now for the tech folks in the room. This is the guy I replaced Mr. Darwin with. John Lambert is, as it says, the distinguished engineer and head of Mystic. Mystic's a cool name. It stands for the Microsoft Threat Intelligence Center, Mystic. Have you guys ever, I meant to ask this earlier actually, so just show of hands, who would say that you work in security? And then what about the rest of you guys? Is it IT, development, leadership? IT?
Technology, but it's always related to security, not
Yeah.
only security, but it's got so connected.
It's always in there, yeah. So Mystic is the team in Microsoft. So we field, so we have a lot of data centers. We have the most of any public cloud service. And we field about 20 trillion authentication signals a day. All the telemetry data we pull back from our Azure data centers. So Microsoft, we always, we eat our own food before we make it available to anyone else. So there's a component in Azure called Azure Data Explorer, and it's like a massive data lake. And we used that for years before it became a public service. Microsoft internally pull all this telemetry back from our Azure data centers, 40 petabytes a day goes into that service. So when we say things like unlimited scalability, like no, seriously, like 2.5 exabytes or something like that in the whole storage array, right? So we're talking a lot. So massively scalable. So I can't remember where I was going with that. But, I was going to say Mystic. So Mystic, Microsoft Threat Intelligence Center, is the team in Microsoft that works on all the stuff that's happening in our Azure environment, if you're an Azure customer. They're the ones that tend to deal with nation-state level attacks. So the stuff was happening with SolarWinds. We were actually helping organizations detect what was going on and recover from that. Microsoft does that a lot. There's a team called DART. There's a compromise recovery team. I used to work with them some. People don't know that Microsoft does this, but we're really good at it. Probably the best in the world, I would guess. There are other people like Mandiant or FireEye. There's other SecureWorks. There's other companies that are really good at it too, but we're right up there. And the Mystic team is the team that deals mostly with nation-state level attackers. These are, foreign governments who have given a blank check to militarized teams of hackers whose job it is to wage cyber warfare. Like, this is the world we live in now, right? I don't have time to go into it, but the amount of information we could share about the stuff that kicked off in Ukraine before Russia ever stepped foot in the country, like stuff was happening for months and months. It's been happening for a long time. So like there are wars being fought all over the world that have nothing to do with bombs and bullets, right? The Mystic team, these are the guys that are mostly involved in that. Now, you'll see I've got not this again up here. It's not repeating something to an annoying depth. What this is about is actually the same stuff just keeps happening. It's really frustrating. Like, when you think about things like SolarWinds, you think, gosh, that's unprecedented. Was it really? In some ways it was, it's true. In other ways, it's the same old thing over and over and over and over again. Like, attackers do not waste their time doing elaborate trick shots if they can just grab the low-hanging fruit. Online Threat Alliance did a study a few years back. Online Threat Alliance their data showed that 93% of breaches are preventable. So 93% of breaches are 100% preventable. Multi-factor authentication, so authenticator on your phone or whatever, you get pinged by your bank when you need to log in, that sort of thing. We know from the data, Google have data that show this, we have data that show this. We know from the data that if you turn on multi-factor authentication, you will stop 99%, depends on the study, 95 to 99% of commodity IT attacks, identity attacks, just by switching it on. Because unless the attacker has control of both devices, they can't get the notification, right? They can't approve it on their phone or whatever. So it just stops short. Is it going to stop a nation state level attacker? No, it will, but then they'll have to find another way around, and they will. That's the way it works. But for most things, 95 to 99% are stopped. So why does this keep happening? It's the same thing over and over again. No, not this again, right? It's the same thing over and over again. I was working with another large bank that we all know and love, and I was sitting with the chief security officer of the organization, and I had done an assessment of their environment, and I had created a report that showed some risks that I was really concerned about. And one of the things I showed on the report said that this organization is very prone to attack through really basic commodity identity attacks because, for example, you don't use multi-factor authentication. And the chief security officer in the room was with her two deputies, the head of cyber, the head of the CISO organization. They looked at one another and they said, I thought we already did that. Like they didn't even know it wasn't switched on. And so when organizations like that get compromised through really basic identity level attacks, everyone wonders why. It's not a mystery. And this is effectively what John Lambert is talking about in this. And what he says is, defenders think in lists, I put, of security controls. Attackers think in graphs. In other words, the security relationships between objects. As long as this is true, attackers win. Now, what does this mean? So there's 1,000 ways to get from A to Z. Attackers are thinking about the security relationships between the path that they can traverse to get from A to Z. Defenders are thinking about, okay, do we have anti-malware software? Check, we got that. Okay. Do we have stuff that's going to scan our email? Okay, check, we got that. And they go down lists of controls, what John's talking about. Attackers aren't thinking about that stuff. What they're thinking about is, I want to get to that, and I'm here, and there's 1,000 ways I can get from here to there. I can go through these systems, compromise these. I can go through these identities and get on these servers, and then that helps me to get on those servers, and then that, right? There's 1,000 ways to get from here to there. And list thinking does not account for that. This includes have you guys ever heard of, maybe just you'll know about it, but there's an organization called MITRE, and they have a framework called the Attack Matrix. Have you ever heard of that, MITRE Attack Matrix? MITRE Attack Matrix is basically a database of tactics, techniques, and procedures that attackers use to attack environments. And sometimes people use that lists, here we are back at lists again, a list of controls, and they say, okay, well, here's this one thing attackers are doing now. Have we got a tool that would help us to define that? Yes, we do. Okay, we're good. All right, and then go down the list, right? And I've seen people actually use the MITRE Attack Matrix. It looks like the periodic table of elements. And like color the cells like a heat map. Like, okay, where don't we have on our list, something that will detect that type of attack, right? Until something comes along like SolarWinds, and what they find out is actually the attack mechanisms that the attackers use were not on that list. They invented new ones. So it's like, again, defenders thinking in lists of security controls doesn't get the job done because it doesn't take into account that attackers are thinking about how to get from point A to point Z, and there's 1,000 different ways to get there. Now, we have a bit of an eye chart again. I pulled this because I used it the other day with a customer, and it was really helpful. Don't try to digest these. What I'm pointing out here, if there's any CISSP certified people in the room, you've probably heard of the Bell-LaPadula model, the BIBA model. These are access control models. They've been around for a long time, years and years and years. Microsoft didn't invent them, okay? Microsoft's privileged access guidance is based on the long-standing security principles represented in these and other security models, such as things like trust is transitive. Does anyone work in finance where you do PCI DSS? Yeah. So the terminology they use in PCI DSS is infectious. So you have PCI DSS is a security framework for people that do payment card processing. Yeah. And you have 3 categories, category 1, 2, 3. Category 1 is called the cardholder data environment. This is the environment where the actual processing of the cardholder information occurs when someone swipes their card or does contactless or whatever. Category 2, though, you can see it here. Here's category 1. Category 2, which is outside of that, these are the things that they're not in the cardholder data environment, but they're connected to it in some way. Why is that important? Well, just like the examples I was given a second ago, if you have, let's say you have a firewall straddling, category 1 is a carved off, supposedly air-gapped network. Don't ever use that term. They're never actually air-gapped. There's always some shared component. So let's pretend there's a firewall here, right? It's got a leg in the cardholder data environment, category 1. It's got another interface on your category 2 side. Trust is transitive. So if A trusts B and B trusts C, then A trusts C, whether you like it or not, or intended it or not. Why is that important? Because you got a firewall here between the 2 categories, and this side of it gets compromised, and they can get on that firewall. Well, what can they do? They can just give themselves access to right into the category 1 environment now, into the cardholder data environment, right? So they use this terminology, infectious, in PCI DSS. So there's special considerations for category 2 devices because the category 2 devices, if you compromise them, can influence the security of the category 1 environment, right? You see that? See what I'm talking about? So again, any subject that's in control of an object is a security dependency of that object. So now this firewall is a security dependency that you have to consider, because if someone gets on that, they can actually give themselves or someone else access into this environment that's supposed to be more secure, right? So trust is transitive, it's infectious. Now these principles, you see them many other places. Again, these aren't necessarily invented by Microsoft. We talked about PCI DSS, NCSC. You guys haven't heard of them, National Cybersecurity Center in Cheltenham. They're the kind of government advising body of cybersecurity here in the UK, NCSC. They have a great article, go Google it. It's called Security Architecture Anti-Patterns. There's 7, I think. And anti-pattern number 1 is illustrating this principle. In other words, they're saying, if you do this, it's an anti-pattern. So it's not a pattern you want to keep using. It's an anti-pattern. It's one you need to stop using, right? Very interesting. Zero trust frameworks. We talked a lot about this already. So zero trust frameworks from NIST, Microsoft, Forrester. They all rely on principles like this. So for those of you that are in cloud, I'll unpack that in a second. For those of you that are in cloud, that are using Azure, but actually not just Azure, any cloud environment, doesn't make a difference, okay? What are some of the guidance that we provide to customers in terms of how to do privileged access well in cloud? I'll tell you a story first of all, which will help to illustrate why we say what we do, right? This tells us what we say, but I want to tell you the why, okay? I was working with a customer recently, but this happens all the time, where you have there's a whole subset of tools called privileged access management. The whole idea is you use these privileged access management, abbreviation PAM, tools to manage your highly privileged accounts. So let's say you have these really powerful accounts used to do really powerful things in your environment, your on-prem environment, your cloud environment. You've got these really powerful accounts. You want to make sure not anyone can use those accounts, right? So you invest in these tools called privileged access management tools. The most common one probably, especially in finance, we run into is a tool called Cyberark. You ever heard of that? Cyberark? Cyberark? Anybody? So what happens is you take these privileged accounts and you check them in to this tool, Cyberark in this case, for example. And if you want to get the password to use that account, you have to go through Cyberark to get it. That's the principle in it. In other words, you can control who can get to that account because only the Cyberark knows the password. We have customers all the time that take sometimes with tools like that, and it's not Cyberark, it could be, there's lots of tools. I'm not picking on that one. That's just the most common one that we see all the time. There's kind of a silver bullet sort of mindset with, we go back to the technology thing. It's like, gosh, technology can just be really problematic. In security, people think, if I just have the right tool, if I just bought the right tech, if I just bought the one magic thing, all my problems would go away. And a lot of times it actually makes it worse because that silver bullet thinking causes people to not think critically about what they're doing. And so one of the things we run into a lot with PAM tools like Cyberark that are running in the on-prem environment, they've been running there for 10, 15, 20 years, been around a long time, these products. They'll take their most privileged accounts. So let's say in your Azure environment, right? And it could be AWS. You've got an account in AWS. You've got a tenant, an Azure Active Directory tenant in Azure Active Directory in Azure. And you have these really powerful accounts called global admins. They can do anything, right? They're God accounts. They can do anything in the environment they want. And so customers think, well, that's really scary. So I'm going to take those 2 accounts, or 3, however many they've got, and I'm going to check them into my Cyberark tool because I don't want just anyone using those accounts. And what they're not thinking about is that in many serious breaches of the on-prem environment, customers' on-prem environments, the first 2 things to fall, Active Directory, Cyberark. So we know of a number of situations, for example, where tools like Cyberark, but not just Cyberark, but tools like that, just in the last few years, attackers have actually compromised those tools and then used them to attack the rest of the organization. And so, in other words, customers are making assumptions that in an outage or an attack scenario, those tools are going to be up and running. That's a dangerous assumption to make, actually, because those tools typically are taken offline by attackers on purpose because they know that if they take them offline, you can't recover your own environment. You just, with this expression in the States, you just painted yourself into a corner, like you're stuck. And so people aren't thinking about necessarily the implications of using these tools. And so to come back to what our guidance is, privileged administration in cloud, number 1, should not be dependent on on-prem accounts, groups, sync mechanisms, authentication, or PIM-PAM tools. And you can see clearly what I just talked about. So on the bottom, the blue row, you've got user access, so normal people doing normal things. Up here, you've got privileged access, elevated administrators doing elevated administratory things. And when you have these shared systems in the middle that straddle both, what attackers do is they compromise this end and then they pivot like that. They leverage those tools as the pivot point to go from this environment to that one, right? And so the reason why we say things like the privileged administration in cloud should not be dependent on on-prem accounts, groups, sync mechanisms, authentication, or PIM-PAM tools is for that reason. Like the tools you use to manage privileged access in the cloud are supposed to be different on purpose. They should not be the same. Now that is not common. That's debatable advice. If there were people from selling some of those tools in the room, they'd all be yelling at me right now. But the reason why we make this advice is because we have teams like compromise recovery, like the DART team. So if you've ever met the DART detection and response team at Microsoft, something very bad happened at your company, because that's what they do. They parachute in. So the DART are the team you hope you never meet. Teams like DART, teams like compromise recovery, okay? I've worked with customers in these situations before. We have people that do it day in and day out, come into customer environments that have been completely melted, by attackers, try to figure, how do we recover this? How do we get back up on our feet? We can't do anything, our whole business is down, okay? Our advice does not come from operational, we're not trying to minimize operational overhead, okay? Because one of the things people say to us is, well, that's great advice, but now what you're telling us is we have this one system. We've always had this one system that manages privileged access for all of our different environments, and it makes it really convenient for our identity and access management team. They got one tool. You're saying use different tools, and that makes it slightly more complex for us, and we don't like that. And what we're saying is, I get that, but from a risk perspective, for these reasons, it's more important. It's warranted, actually, for there to be a degree of operational discomfort, if necessary, for really highly privileged access, than it is to have just one tool that makes it really easy for everyone. Because actually you need to break, if you don't break this link, and I'll show you this on the next slide. This represents, you know, all the privileged stuff that you access. Here's all the other things. You've got all these access points that attackers can use to pivot from one environment to the other, to pivot from the on-prem environment to the cloud environment. You cannot faff around with these pieces and try to mitigate this risk and that risk. You have to break this attack chain. You have to break the attack chain to mitigate these risks. When you look at an attack like a solar winds that happened, well, how did that go down? Well, it was super advanced. It wasn't really, not in a lot of ways. It was very sophisticated. It wasn't necessarily advanced. If you look at what those attackers did, they did things like they got control of the on-premises Active Directory. They moved over to the Federation infrastructure because they were a federated organization. They attacked that. Once they had control of the Federation infrastructure, they could mint their own SAML tickets, impersonate anyone they wanted in the cloud environment. Now they pivot up to the cloud environment with a SAML ticket that says, I'm a global admin, let me in. Okay, cool. I trust that Federation infrastructure because you told me to trust it, so I'm going to trust the tickets it gives me. This guy's telling me he's a global admin. Let him in. And that's what, you know, so they get in there, and then they get service principals and user accounts, and they grant permission to those user accounts to read all email for the whole organization. But I know that no one's monitoring that service account because I've been watching this organization for a while, and their monitoring strategy is not very good. So I'm going to grant permissions to this account to read all email in their entire Exchange organization. No one's going to even notice that. And then I'm just going to sit there for 6 months and watch as this organization and every person in this organization talks. I learn about their outage windows for when they patch servers. I learn when the CFO is going to be out of the office. I learn what the CISO is doing on Thursday night. I learn when the IT admins are all out on holiday and they hope nothing breaks because there's no one to cover for them. I learn when the change freezes are for Christmas. I mean, do you think it's coincidental that they did this over Christmas? It was not coincidental because no one's around. They know that because they've been watching the email. They know this, right? So again, that all happened not through, well, there were some very sophisticated, very advanced things they did, but in general, taking control of Active Directory, moving laterally to other devices, escalating their privilege up to higher privileges, granting themselves permissions to do things. They could then watch the organization. They could begin to exfiltrate data out of the organization. That stuff's been happening for 20 years. It's the same old thing over and over again. I mean, honestly. And when you think about organizations, and we have some evidence of this, organizations that took principles like assume breach, put controls in place like MFA, strong MFA, not text messages on your phone, but strong MFA with a hardware device or an app on your phone. Those organizations didn't get hit like this. Now, nation-state level attackers coming from other countries around the world that love to fund that kind of stuff, they get blocked, they'll try to find another way in, okay? But the organizations that took this advice and really put it into practice, they were resilient, but everyone else wasn't, and it spread, and it got worse. So the model that we use Just got a couple more and we'll wrap up here. The model that we use in Microsoft is this one. This is called the Enterprise Access Model. And essentially what we do is we divide the world up into planes. You may have, we had an old model based around tiers, so tier 0, tier 1, tier 2, that language. This enterprise access model uses the concept of planes. You may have heard that. Have you heard that terminology? Control plane, management plane. Yeah, okay. Control plane is always identity. Now, people sometimes use that word contextually. What's the control plane in this circumstance? But actually, control plane is always the same thing. It's identity. And the reason is, again, just like I said, the order of the letters GRC are really important. The orders of the layers are important. If you own this layer, guess what else you can own? Everything underneath it. Because if you own privileged access, right, you can own the control plane, the identity mechanisms. If you own the control plane, you can essentially grant yourself or someone else access, just like happened in SolarWinds when they got control of a privileged account and granted a service principal access to read all the email, right? So if you own the privileged layer, you can own anything under it. So the layers are important. So control plane is about identity. Management plane, typically for you IT guys, is the piece that extends across all your infrastructure in the cloud environment, for example. So that's a really important plane. Obviously, if you own that, you get access to a whole lot of data and specific workloads running in that environment, right? And then, of course, at the bottom, you've got users coming in either directly or through APIs. So this enterprise access model kind of codifies some of those principles. But if we look back at, I don't think I read the others too, so let me just go back here. If we look back at the others, privileged administration in cloud should not be dependent on on-prem accounts, groups, sync mechanisms, authentication, or PIM-PAM tools. Now you know why we recommend that. Privileged administration should not be performed from normal productivity workstations. We talked about that one, yeah? That's a tough one, because who wants to carry around 2 laptops? Well, maybe you don't have to do it that way. But if you're talking about your global admin account, you're talking about your domain admins, tough it up, guys. Like, come on. Like, you're talking about literally carrying around the Coke secret formula that you pretend you couldn't Google it. And then no standing privileged access. So if we go back to our zero trust principles, right? Assume breach, verify explicitly, least privilege. Okay? You should not be putting people into highly privileged groups and then leaving them there. There should be a mechanism whereby people have to request access to a highly privileged role. And in the Azure ecosystem, we do this with a tool called Azure PIM, Privileged Identity Management. But it's different from what I was describing earlier with the on-prem systems. It's cloud native. So what we say to customers is, hey, if you've got a tool, you want to use that to manage your privileged accounts on-prem, do that. Just don't use it to try to manage the ones in the cloud. To manage cloud stuff, use cloud tools. And that's the advice. So now you guys kind of understand that. So last line, we'll wrap up. Closing thoughts. Back to the beginning, collision of cultures. So you can't become a butterfly by trying to be a better caterpillar. Another great quote. Have you established a mandate, those of you that are in leadership, have you established a mandate for change? Can you drive change through your organization? If not, what are you going to do about it? And what about you personally? Are you kind of stuck in the world where you're an expert and it feels scary to become a novice again, or are you a learner? Is it okay to embrace new things and just accept that you don't know it all, and that's okay, and it's about moving forward, and that's what progress looks like and feels like. Form and function. Structure impacts effectiveness more than we like to admit. Have you defined and empowered modern security roles and functions? Look back at that slide. When, not if, adopt and assume breach mentality and embed it at all levels. It revolutionizes the approach to security, your effectiveness. I should have mentioned, if you operate from the assumption that you're going to be compromised, it takes your focus off of how do we prevent this, and it puts it on how do we detect and recover from it. It's about failing fast, because if you operate from the assumption that even the best people are going to get compromised eventually, but you can do something about it by detecting it and recovering fast, right? That's the key. So I'm not saying we're not trying to prevent things. We're still trying to prevent things. It's just now we're focusing a little more this direction, okay? Principle enable for zero trust. And then the last thing, not this again, you have to break the attack chain used to pivot from on-prem to cloud. Tools used to manage privileged functions in the cloud are supposed to be different. And ultimately, for privileged functions, highly privileged functions, the risk that you're incurring is more important than the operational overhead. That's just a reality. So with that, I'll close. I hope that was helpful. If you guys have any thoughts, any questions, we'll put it up. Yeah.
Yeah. Which company do you work for again? No.
Microsoft.
No, what you're saying, I mean, in regard to the technology, it's not the problem of technology, it's the Okay, well, I won't do the which company you work for question, but I did it anyway. Yeah, I completely second what you're saying about, the problem is not necessarily with the technology, but the culture within a business. But you can, and that's, on the companies that use technology, but on this, if you look at the culture within the technology providers, they have a culture as well. Yeah. And it's driven by a commercial model, and that is to sell technology. So how do you see that, in the industry, how is that compatible? Because it's always driven by, it's not driven by, are you actually utilizing your current technology properly? Not necessarily, it's rather, you need this tool, or hey, you need this license. So how do you find that compatibility with that?
Well, I find it really frustrating. Because I said, early on, I said in my role is to be a trusted security advisor for my customers, not to be a Microsoft fanboy. And that's really important to me. And actually, we're given license to do that. There is a tension, because, when I was working in management consulting, right, you have the luxury of being a kind of pure play, when you work for a company that makes and sells security products and services, they naturally want you to, hey, why don't you try to sell that, Now, I don't work in sales. I don't have a commission. It doesn't matter to me if people buy stuff or not in that sense. I don't get kickbacks or anything like that in my role. There are, of course, many sales roles that are, commission driven. And I would say there are many times I get really frustrated because there is a tension. There is a tension between people who are, now it's important for me to say I wouldn't be at Microsoft if I didn't believe in what we were doing. I would be at Palo, or I'd be back in management consulting or somewhere else. I'd be somewhere else, right? Like those messages that I was saying earlier, identity is the new perimeter, like those are still very countercultural. That ethos is still very countercultural. That's ultimately why I joined Microsoft, because I believe in what we're doing. But there are definitely times we have people, one of the things that happens, and this is really frustrating in the account teams in Microsoft, some of you will have experienced this, I'm not giving anything away. A customer will spend many, many hundreds of thousands of dollars to buy licenses like the E5 licenses, which is basically like, if you get E5, you get everything, all the tools, you get all the goodies, right? They spend lots of money to get the E5 licenses, they get all this stuff, and then 3 years later, or whatever their contract term is, they haven't used hardly any of it. So now they're talking to the account team about, let's go down to E3, because we're paying for all this stuff we're not even using, right? And the Microsoft guys, the sales guys, the account teams are like, dang it, this is really terrible. We have to convince them to stay, And I get it, but the thing is, and I think the thing people forget, unless you've been out in the real world and not living in a bubble, again, back to the tech thing, it's great, it's easy to buy a tool. It's really hard to operationally land it. And especially if you're talking about something like data loss prevention tools or something like that, where, a lot of organizations we work with, they've been using DLP suites from people like Symantec or things for 10, 15 years. And so they have an organization built around these tools. And now here we come, we rock up and we say, here's your E5, here's your DLP tools, have at it, Tiger, And it's like, and they're like, well, the operational teams are usually not involved in the decision making. So the CISO or someone says, we bought this thing, you need to use it. And they're like, well, I've never even seen that thing. Like, we don't have any skills. Like, how do we land this and operationalize it? Now, I understand that because I've lived in the real world, right? But a lot of people, you know, if they're just in sales and they haven't done that, they don't know that. And so to answer your question, you know, it can be really frustrating. And I think what makes it work is it's like a rubber band. You have to have tension on both ends. If we only had one or the other in Microsoft, it wouldn't work. So yes, we have people that are selling stuff, but we also have people like in roles like mine and many others. There are many other roles like mine in Microsoft whose job it is to be a trusted advisor, even if we're not towing the party line, as it were. So, is that helpful? Yeah, sir.
Hi, Ben.
Hey.
Thank you for your presentation. It's very interesting. You like quote?
Sorry?
You like quotes, yeah?
Yeah.
I would like to share a quote with you.
Okay.
It's not my quote. It's from a detective constable from the London Metropolitan Police.
Okay.
Okay? Are you ready?
I'm ready.
If you want to solve a crime, think like the criminal who committed it.
Yeah. That's a good one. Very good.
So this kind of mindset will be applicable
Yeah.
in the cybersecurity world.
Yeah.
You have to think like a criminal.
Yeah, and there's disciplines like threat modeling. You may have heard of things like threat modeling, where that's the whole thing is you create a system diagram and then you use a mnemonic like STRIDE. There's lots of different types of ways to approach threat modeling. We use one called STRIDE. Each of the letters stands for something. Like S stands for spoofing, like it's an authentication type of attack. And you pull it apart, and then through those 6 lenses, you look at your diagram and you say, how could someone in this environment impersonate someone else? How could someone, you go through the list. And it's all about that, actually. And in fact, if you don't do that, like threat modeling is a really important part of...
Your fifth vintage principle.
Yeah, good idea. I have a list of a bunch of others. I'll add that one. Good.
I have a question around artificial intelligence.
Yeah.
And, you just mentioned that it's just an area that would be growing. What are your suggestions? How to approach? What
Yeah.
would come into mind?
Yeah. So let me answer that by sending you some stuff. So I don't work in that area directly, and it's a huge, so one of the things I really like about Microsoft is, so one of the things we've advocated for a long time is a digital Geneva Convention. So, the Geneva Convention sets all kinds of rules around warfare. You can't attack civilians. Well, those rules don't exist in the cyber warfare space.
No.
And I know if you're a criminal, you don't obey the rules, but still, there is an important point to be made. If there were some sort of digital Geneva Convention, something like that, where we could say, look, civilian water infrastructure, it's off limits. Like, you want to attack the military, then you attack the military, So we've advocated for those kind of things for a long time. I mentioned that because AI is another one, so responsible. The reason I'm not going to answer the question is because we actually say a lot about responsible AI. What does it mean to create artificial intelligence that doesn't disenfranchise people based on their characteristics? Because in the past you've had AI models or machine learning chatbots that have been either like flagrantly racist, focused on different things that can be skewed in one direction or another based on your socioeconomic condition, where you were born, how much money you have. Decisions made about whether you can get a bank loan or not based on, your gender and the kind of job that you have and things like that. So people can use AI and machine learning in ways that's unethical. And we say a lot about, okay, what does responsible AI look like and what guardrails should be put in place? In addition to that, though, we have a whole series on threat modeling about how do you threat model and protect machine learning data. I started a blog article, I haven't finished it, but we have some really good stuff publicly available on that I think you should look at.
It's evolving.
It's really helpful.
I'm interested.
Yeah, I am too. It's fascinating to me.
Yeah.
When you read about all the things that people have done in the last couple of years to use ML in an adversarial way, it's scary.
Yeah, and this could be our future.
Yeah.
That's why
Yeah.
it's important.
Yeah.
Thank you.
Yeah. Yeah, so David or Dallin, just
we've
remind
got
me on
time
that.
for one more question. This
Yep.
one's online from Tom Gilb. Is there some unified digital model of everything you've recommended for security, showing how things are connected?
So there is to a degree. So some of these are just statements of principle. And these are principles that we follow. You find statements of principle in lots of different places in the Microsoft ecosystem. I would say the most common place where we talk about some of these principles is in what we call the Cloud Adoption Framework, CAF, Cloud Adoption Framework. We talk about a lot of these security, there's a whole, it's not just about security. Cloud adoption is about, what are the business drivers for why you even want to do cloud? What are the expected business outcomes you want to see from the adoption of cloud, so on and so forth. But there's a whole section on security, Tom, that talks about a lot of the principles I've discussed here. And a lot of the securing privileged access guidance that I reference here, some of these slides you'll recognize, in the Microsoft Cybersecurity Reference Architecture and in the in the securing privileged access documentation come straight out of this. So Dalim or David, one of you guys can remind me the information you've asked about for machine learning and also for the pulling together some of the digital reference material for some of the security stuff. I can send links for that.
Sure. Okay, well, that's great. Wow, what a wealth of information and very useful. Thank you very much for the questions from the room here and from the cloud or wherever other people are. Thank you very much for being part of this session, but especially please join me to thank Ben.